Okay, quick review of the week. So let's take a look. Simplifying first. Okay, so 4 radical 98. Let me simplify this. There's the 4, which I'm just going to leave it as a 4. I'm not going to do anything with the 4. Now 98. I'm going to think, can I break that as to 2 radicals? I'm thinking 98, two numbers that multiply 98, but one of them has to be a perfect square. What I mean with perfect squared is like 4, right? Because I know the square root of 4, 9, 16, on and on. So two numbers that multiplied are equal to 98. One of them is a perfect square. Now here I'm going to think of 49 times 2. 2 is not a perfect square, but 49 is, right? The square root of 49 is 7. I look at my radical that I have left over. Can I do anything better? No. Okay, so now multiply your whole numbers. So this is going to give me 28 radical 2. That way you're going to type this 28 radical 2. Now number 18. Now this is the funny one. It's a lot of people is like, all right, the 3 on the outside, just going to leave the 3. Now radical 36. Many people break this as 4 times 9. The square root of 4 is 2. The square root of 9 is 3. So I don't have any more radicals. Everything cancels out. Yeah, the square root of 36 was a perfect square to begin with. Now multiply your whole numbers. I'm looking at 3 times 2 times 3. So that's going to give me 18. I don't have radicals in my answer because the radical given was a perfect square, right? A perfect square simplifies to a whole number. So I don't have radicals anymore. Okay, cool. Let's take a look at question number 19. We talk about the Pythagorean theorem, and this happens when we have a right triangle. The biggest side, I'm going to call it C. The hypotenuse is C. And the other two are called legs. One of them is going to be A. The other one's going to be B. It doesn't matter which one's which. So I'm going to call this A, B, and C. The hypotenuse is C. Let me square each of my sides. 13 times 13 is 169, right? So I'm just going to go 169. X times X is X squared. 16 times 16 is 256. So I squared each of my sides. We learn, during the week, we learned the Pythagorean theorem. A squared plus B squared is equal to C squared. Hopefully you did ask, as I mentioned in my lecture, hopefully you did ask person in construction for the 3-4-5 rule. And then you told them that they're working Pythagorean theorem. Hopefully you did that. So, okay, so we have A squared plus B squared equals C squared. So I have 169 plus X squared is equal to 256. This 169, let me move it over as a minus 169. That's going to give me X squared is equal to 87. So that means that X is the square root of 87. Now break this, simplify if possible. Now think about this. Can you break this into two radicals where one of them is a perfect square? So 4, 9, 16. Right. Nope, neither of them work. So cannot simplify. So square root of 87 is simplify. The way I'm going to type this is going to be radical 87. Let's take a look at number 20. Let me square everything, right? So I'm going to say this is X squared. This is 144. This is 225. When I label my sides, the hypotenuse is C. the one that is farthest away from the 90 degrees. The other two are called legs. One of them is A, the other one's B. So let me write this as 225 plus 144. It's equal to x squared. 369, it's equal to x squared. So x must be the square root of 369. Okay, let me see if I can break this. I know my smallest it's a 4. Now 369 divided by 4 gives me a decimal. Can I try a 9? Let's see. 369 divided by 9 is 41. So 9 times 41 is 369. I know the square root of 9 is 3, so this simplifies to a whole number. Now 41, nothing I can do. So my answer will be 3 radical 41. The way I'm going to type this will be 3 radical 41. Same idea, but without pictures. Find the missing side of each right triangle. Side C is the hypotenuse. Sides A and B are the legs. Leave your answers in simplest radical form. Okay, so if I was squaring, let me square each of my sides. If I'm squaring B, B squared is 64, right? 8 times 8. It's easy to when you square a whole number. Just multiply it by itself. It's even easier when you square a radical. Square root of 226 times the square root of 226, you just get 226. Now the problem will be what happens when you squared a whole number in the radical. I'll come back and refresh your mind on that one. So it seems like I don't have A, right? I'm solving for one of my letters and I don't have A. So that's the one I'm solving for. So I'm just going to go A squared plus 64 is equal to 226. My 64, let me move it over. So minus 64. So I get A squared is equal to 162. So that means that A is the square root of 162. Now simplify this if possible. Okay, let me break this into two radicals as 81 times 2. I know the square root of 81 is 9. So my answer will be 9 radical 2. Here, let me say that 10 squared is 100. 12 squared is 144. Seems like I'm missing A again. So let me go A squared plus 100 is equal to 144. This plus 100, let me move it over as a minus 100. So I have that A squared is equal to 44. So that means that A is the square root of 44. Now, square root of 44, I can break that as 4 times 11 because the square root of 4 is 2, right? So my answer is 2 radical 11. So I'm going to go 2 radical 11. Okay, I said I was going to come back. Here, number 21. Remember when we have a whole number, it's easy to square a whole number, right? 8 squared is 64. When you have a radical, it's easy to square a radical. So let's say, what if I have a combination? So let's say I have like 5 radical 3, and I have to square that. Let's say I came in and said in a question, B is equal to 5 radical 3. So what's B squared? If I only had the 5, it's easy to square, right? 5 times 5 is 25. If I only had the 5. If I only had the radical, That's easy. 3. It's easy to square a whole number. It's easy to square the radical. Now, when you have both combined, 25 times 3, I will say b squared is 75. So again, if you have a whole number, whole number. If you have a radical, just square the radical. When you have both, square each and then combine. All right, let me zoom out so that you guys can see what we did today. There you go.